Hello students, hello parents, welcome to Concept Clarity. This is our final session on magnetism. That means magnetic effect of current as per class 10 syllabus. In the previous session, we have seen the behavior of current in a circular loop and in a solenoid. We have seen how the magnetic field lines actually appear for a circular loop and solenoid. The solenoid behaves like a bar magnet. So in today's session we are going to see the magnetic field and how the magnetic field actually produces a magnetic force. Can it produce a magnetic force? That means current in a loop or current in a wire should be able to produce a magnetic force. Amazing. Maybe a different setup is also there. So then we can use that in motors and medicine as well. We are going to see how we are going to use them. And then we are going to see a domestic electric circuit. Okay, what are the common voltages and current? And then we are going to see how overloading is caused at our home. Sometimes in our homes we see like धुआं आ गया, smoke आ गया. We should be able to understand why the smoke is caused. We'll understand those reasons as part of overloading and how to prevent that overloading, how to prevent that धुआं, how to prevent that smoke at our home. Very important. Okay, let's proceed. So we conducted an experiment. In this experiment, we took a aluminum rod. Okay, this is your aluminum rod. AB is an aluminum rod, and this is connected to your battery and a switch. That means we are intending to pass current to the aluminum rod. So imagine my hand here. This is my hand, and this is the aluminum rod itself. Okay, I'll show the like a rod itself. Okay, this is the aluminum rod. Okay, now current is passed towards me. Current is passed towards me. Okay, the circuit is made in such a way that the current is passed to the to the rod towards me. And now I place the horseshoe magnet. The horseshoe magnet, the thumb of the horseshoe magnet, which is the north, and the fingers of the horseshoe magnet is actually the south. So the magnetic field line of the horseshoe magnet will go from north to south. That means it will go from down to top, right? From my thumb, it will go to the fingers on the top, right? And the current is flowing towards me, right? So this is the experiment. So let's see what happens. When we place this experiment, and these are the steps, exactly whatever I have told. Okay, aluminum rod is placed, the dimensions are given, horseshoe magnet is placed, north placed down, and south is placed upward. And now we have a variable rheostat also, we can change the magnitude of current. As the current is passed to the aluminum rod, current is passed towards me, and we have this bar magnet here, horseshoe magnet. We see that the aluminum rod gets deflected. Get deflected, and here it shows the deflection towards the left. Towards the left. So amazing. We can use a coil around two magnets placed like this in such a way that they produce magnetic field line, and the coil, that is the copper coil, gets continuously deflected. That means it will behave like a motor. It will behave like a motor. I will share another experiment in a short to demonstrate that as well. Passing through a coil in the presence of a magnetic field will show the motion of the coil by itself. Okay, so please like and share so that you can see those experiments as well. So what is the direction of this force? We know that the rod has got deflected. Is there any direction? So the one way of identifying the direction is the Fleming left hand rule. So the force is the thumb, and the index finger is the magnetic field, and the current is the direction. The force is the thumb. First you always point the index finger. That the index finger was like this, right? Magnetic field was upward, and current was coming towards me. Current was coming towards me. So the force was on the left. We have already seen that experiment. The force was towards the left. Is there any simple way, sir? Is there any other way? Right hand rule also is there. Right hand rule, thappad rule. Okay, commonly known as thappad rule. Okay, right hand rule. Here what we do? Thumb. As you know, thumb was always the current. So thumb is the current. It will point towards me. Okay. And this, the magnetic field going from down to up. So the force will be on the direction of the palm. That means this is the force. Thappad wala force. Thappad wala force. Okay. Both Fleming left hand rule and right hand rule gives the same direction of the force. So it proves that you can apply both methods to identify the direction of the force. Next, so because of this force, because of the magnetic force, they're not just theory, right? They actually exist. We have seen the deflection of the aluminum rod. That means actually the force exists. So we can use this concept to make instruments. We can make electric motors which convert electrical energy into mechanical rotation, or electric generators which convert mechanical energy into electrical energy. Then loudspeakers, when a current is passed in a coil and magnetic field also is produced, then it produces sound and vibration. On microphones, we can convert sound and vibration into electrical signals through electromagnetic induction. Okay? Electromagnetic induction is something which we will study in class 12. Okay? Then there are various other instruments which measure the current as well. We can convert galvanometers into ammeters or voltmeters, okay, which can experience the force, magnetic force. Because of this magnetic force, current producing magnetic force will cause a deflection in the needle. Thereby you can measure the current flowing in the wire. So remember, so because of the magnetic force, you can have motors, you can have generators, speakers, meters, all because of current, all because of current producing this magnetic field. And because of the magnetic field, you can produce a magnetic force. You can take advantage of this and create all sorts of appliances to help us, of course, in our daily life. What about medicine? Medicine as well. Oh, before we go into medicine, we have a question here. It says an electron is entering a magnetic field at right angle. That means at right angle. Electron is entering a magnetic field. That means the direction of the current will be opposite to the electron. So that will give you the answer. Okay. Answer is D. You can read to this. We have already explained Fleming left hand rule. You can use that to find the direction. Only remember that it is given here electron, and the direction of current is opposite to the flow of the electron. So you have to consider the direction of the current with respect to magnetic field. Next, magnetism in medicine. In our own body, हमारे शरीर में भी बिजली रहती है. That means current, electricity is passing through our body. That means when we touch something, we can feel that. We can feel that because there are electrical impulses passing all the way to the nerves. And because electricity is passing, obviously magnetic field also will be there. But it is 1/1000th. It is what? 1/1000th of the Earth's magnetic field. It is very, very small. But which are those organs which have very high magnetic field compared to the all other organs? It is the heart and the brain. दिल और दिमाग. दिल और दिमाग में magnetic field ज़्यादा होती है. And because of this magnetic field in our body, we can use this to capture images. We can use this to capture images and help us identify in diagnosis if there is any tumor or any inconsistencies in different organs of the body. And that technique is called as the magnetic resonance imaging, MRI. You must have heard that. Okay, it is used in medical diagnosis. Okay. So what about our domestic circuit now? This is a domestic electrical circuit. Sir, what is this? Domestic electrical circuit here. We have seen now. We have seen electric meters kept at the bottom of our flats, and all the electrical lines come into that meter, and then from the meter it comes to our home. And in our home we have another switchboard, master switchboard, which can control the electricity in different rooms. That means now the meter will measure how much consumption is taking place in our home. Every unit run, kilowatt run. 1 unit, 1 kilowatt hour. Hope you have seen the previous video. If you have not, please do watch it. Okay, so what we have here? We have a live wire, sir. We have a live wire shown in red. Red is live wire, means it is carrying current. And then the green wire. Green wire is earthing wire. That means this wire will connect all our appliances, right? If the appliance supports connection to the green wire, then it will be connected to our appliance, and then that wire, green wire, will also be taken to the earth, actual earth. Will be connected to a metal plate, and then that metal plate will be connected to the earth. I will show it in another shot. Okay, I will show it in another shot. It is there in my building as well. And then the neutral wire. The neutral wire is a black wire, which will help to establish and complete the entire circuit when the switch is on in different rooms. So what is the typical voltage in a home? Typical voltage is 220 volts. Okay, if you measure using a multimeter the voltage in any of a socket without any adapter, okay, it has to be direct socket. You will see 220 volt. And current, you will have two types of current. One is 15 amp current and 5 amp current. That means basically the socket will support either 15 amp or 5 amp. So 15 amps is the socket where you will connect high energy consuming devices like geyser or immerser, or they consume very high power, right? Or it could be even a high powered fridge if its consumption is high in terms of wattage. Okay. The next is basically 5 amp. 5 amp sockets connect to low consumption appliances like bulbs or fans. The low consumption devices will connect to 5 amp sockets. Okay. Earth wire, as I explained, it will connect the metallical body. If you have a fridge, the outside of the body of the fridge may be metallical. That means the fridge will have to support one pin, will have to support, that is the middle pin, will have to support the earthing wire. That means it has to connect to the earthing wire. And that pin is indirectly connected to the metallic body of the fridge. So now if there is a leakage in the fridge of the current, live wire might touch any other metallic body, it might touch by accident due to some reasons. We will see why those live wire gets touched. Okay, so because some reason it touches, and the metallical body also gets electrified. If you touch it, you'll get a shock. You might die. Right? Better use a slipper before you touch any metallical body. So before you touch, if the earthing is there, then the entire current will go to the earthing. That means the low resistance circuit will pass to the low resistance circuit, and hence you will not get the shock. Okay, most of the circuits, most of the appliances are parallel in nature. So if one of the device stops working, the other device can still continue to work. Okay, that is why most of our connections at home are parallel in nature. We have shown this. These are all parallel. So this is how a domestic electrical circuit actually works. Okay. So next, overloading. Overloading. Why is overloading caused? By mistake, a live wire might touch a neutral wire. A live wire directly touching a neutral wire is actually a short circuit, right? There's no resistance. Imagine how much heat will get produced. All the current is passing to the neutral wire without going to any resistance. It will damage the wire. The insulation of the wire might get damaged, it might get burnt, right? Or there may be a fault in the appliance also, due to which the live wire might touch the neutral wire. Accidentally, supply voltage might get hiked. The supply voltage can get accidentally high. Suddenly there may be a surge of voltage. Sometimes you would have seen, no, that the transformers get sparks like Diwali sparks occur. Due to which, that means suddenly there's an overload of voltage. That is why the overload of current which may come in your home, right? And your devices, your costly devices like fridge or TV, might get damaged because of this high current. Okay? Or sometimes you may connect too many appliances on single socket. कभी हमारे पास एक extension board होता है. Sometimes we have an extension board with multiple sockets, and that extension board has a particular rated current. But now you connect all sorts of devices. It had happened. It had happened in my own home, unknowingly, right? As kids, you try to connect multiple devices without knowing the current requirement of the other devices. So that means the device, that is your extension board, will get overloaded. It will spoil the devices which are actually connected to it. Okay, so how to prevent it? In such situation, what happens? Current in the circuit abruptly increases, thereby causing short circuiting. Okay, how to prevent it? We use an electric fuse. Electric fuse, we have studied that electric fuse is connected in series with the device, right? It works on the concept of Joule heating. That is, when high current passes through more than the capacity of the device, then the fuse has to shut off. The fuse has to melt, and because of the melting property of the fuse, the device will get protected, right? The current no longer flows to the device, and that's how you protect your device from overloading. With this, we come to the closure of magnetic effects of current for class 10, and this is also helpful for class 11 NEET as well, as a basis for your current, electricity or magnetism as well. Okay, so please like, share and subscribe, and do share it with your friends as well. See you until then.